What's up, class? I wanted to make one more quick video just to try and kind of get you warmed up for your quiz. If you need a refresher, remember you can use your notes on the quiz. You may use a calculator, but it's kind of nice to be getting our brains thinking about some of the tougher questions you might see. So I'm going to make this full screen, and we're going to do a couple questions that are similar to ones that are on your quiz. All right, so if you want to graph this on the graph, we can't even begin graphing until it's in factored form. So sometimes they're going to be given to you. There will be several problems where they're not in factored form, but that's going to be your first step. And remember, to get it in factored form, you want to look and pull out the GCF first, which in this case is x. And what will be left over is x squared plus x minus 6. Now we still can't graph, so because we got to figure out if this is factorable here. We know that one of the zeros is going to be 0 because we have a lone x in the front. So that one we know for sure. Now the question is this thing factorable? Can we find factors of -6 that add to 1, and the answer is yes. That would be x plus 3 times x minus 2. Those two numbers multiply to -6 and add to 3, giving us the following zeros. -3 will be a 0, and +2 will be a 0. Those are our x-intercepts, okay? Our y-intercept is also 0. Keep in mind if this x, or you may have a problem where you don't have the y-intercept of 0. And remember, to find the y-intercept, all you have to do is plug in x equals 0. If you do that, you'll be able to find the y-intercept. We don't need to do that here because we already know what it is. The next thing we need to think about is end behavior. The way that we do that is by figuring out what the first term is. Well, it's already in standard form right here. So x to the third is my first. It's odd and it's positive, which means my end behavior is down and up, which means my polynomial is going to aim down this way. And then on this side is going to come up in this direction. Pretty exciting. Okay, and I mean, all that's left is really multiplicity and connect the dots. Now take a look. You should know that multiplicities determine how the polynomial interacts with that 0. So if all of these have a power 1, which means all of their multiplicities are 1, which means this line is just going to come directly across here. It's going to come directly across here and directly across this direction. So there's not going to be any crazy, coming down and then just barely touching the 0 and taking off in the other direction, or any, swerving towards the degree 3 or multiplicity 3. So this one's pretty straightforward, but you should have those pictures in your notes somewhere if you get one that isn't like that. Now, if you want to make this accurate, we would, plug in a value halfway between our zeros to try and get an idea. So why don't we do that? So let's plug in x equals, what is that, -1.5. If we plug that in to our function, you can plug it at any step that you want. I'm going to plug it in right here because I think this is the easiest. That will look like y equals -1.5 times -1.5 plus 3 is 1.5, and -1.5 minus 2 is minus 3.5. And then we can get out a calculator, do some multiplication. That's a negative times a positive times a negative, so my answer is going to be positive, and it better be, because I'm plugging in this halfway point right here, right? So I know that it's got to be up here somewhere. So I can kind of forego those minus signs. 3.5 times 1.5 times 1.5 is 7.2. 875. So I'm going to go up to like right there. So it looks like polynomial is going to go up and kind of get to the very top. We'll have a what's called a local maximum at roughly about that spot. If you go to the halfway point down here, that's at x equals 1 between these 2 points, then we get a y value of 1 times 1 plus 3 is 4 times 1 minus 2 is negative 1. Okay, which is negative 4. So down here it will be at negative 4. So now let's finish our polynomial. And some of my original lines, you know, you can erase these if you need to, if you think that your first ones weren't super accurate, which I don't, but that's okay. So it's going to come up like this. It's going to come up, it's going to touch that point, it's going to come around, it's going to come directly across, come around, touch this, and head off in that direction. So that's how you're going to graph and show your work on a problem like this. Now I may have given, I will have given some of the ones on the quiz in factored form, and you don't have to factor. The last type of question I think that students are going to struggle with is taking this and writing the equation of the polynomial, right? So with this one, it's just this process in reverse. Go through, find your zeros, but on the quiz it'll say, don't assume that the leading coefficient is 1. So I know that my polynomial is going to be y equals some number a times, now we plug in our zeros, it crosses at negative 2. So x plus 2, because negative 2 plus 2 is 0, x plus 1, and x minus 1. So I know that my function is going to look like this. Those are my 3 zeros. Now let's check their multiplicities. This goes directly across, directly across, directly across. So all of them just have power 1, similar to the polynomial we saw in the previous example. But this is not my completed equation because I don't know what a is. I don't know if this thing has been stretched or compressed or anything. So what we do to find that is you just pick a point that you know the polynomial goes through. I'll be picking 0, 4. So 0, 4, we plug those values in for x and for y. That's this point. 0, 4. So we'll put a 4 in for y and a 0 in for x. So that's going to look like 0 plus 2, 0 plus 1, and 0 minus 1. Simplifying, we'll get 4 equals a times 2 times 1 times minus 1. Okay, multiplying all those together, you'll get 4 equals a times negative 2, and then or negative 2a. We divide both sides by negative 2, and you'll get a equals negative 2. Now we're still not done. It says write the equation of the polynomial. The final equation is y equals, now you got to plug in a, negative 2 times x plus 2 times x plus 1 times x minus 1. Alright, that's it for this video. Hopefully good luck on your quiz, and we'll see you guys Monday.